Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 44. So first of all, apologies if my voice sounds a little bit croaky. My kids have brought something home from school and this week we've all been a little bit rough. But don't worry, I'll make sure I edit out any coughing or anything. But of course the show must go on, and today I'm joined by Poornima Nayar to chat all about gRPC. So welcome to the show, thank you for joining us.
Hi Dan. Thank you for having me as your speaker on the show today. It is a privilege and I'm excited to talk about gRPC. But for those who don't know me, my name is Poornima Nayar. I am a freelance .NET developer and currently I'm doing a lot of consulting work, and I'm also the acting CTO for agency in Sweden called WebMind SC. I'm a Microsoft MVP for developer technologies, and I'm also an Umbraco MVP. For those who don't know Umbraco is a .NET-based open source CMS. A lot of my day-to-day job is involved with building web applications and websites with Umbraco, and I do a lot of community activity as well, both around .NET as well as Umbraco, as you can clearly see. I am also one of the members of the advisory board for Umbraco Hardcore, which is the headless Umbraco CMS. So exciting times there. And non-work me, I'm a mother. I have an 8-year-old daughter. She's turning 8 actually next month. I do a lot of reading, like non-fiction, fiction, whatever. I just love reading. And I'm also a student of Carnatic music vocals. That singing is like my unwinding thing. If a cup of coffee, a sleep, the last step is music. If me singing cannot fix something, then that problem is beyond my hands for me. So that is me in a nutshell.
That is a lot of stuff. It's interesting with most guests I have on there's some kind of link with music. It's like a lot of people have guitars in the background. I've got one there. But yeah, don't worry, I won't try to sing because that'll get rid of all the listeners. So before we dig into gRPC, I'm going to quickly do this episode's listener mention. And this one goes to Carl Saganar, and he tweeted, "What a fantastic intro to Docker in this episode of the Unhandled Exception podcast. Even though I'm not a total Docker newbie, I picked up some awesome tricks." So thank you for your tweet, Carl. And if you want to be mentioned on the show, just send a tweet using hashtag #unhandledexception. All feedback is greatly appreciated. And I'm Dracan on Twitter, which is DRACAN. And don't forget that this podcast now has its own Slack channel. And if you head over to the website unhandledexceptionpodcast.com, you'll see a big shiny Slack link there. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. So, I've not used gRPC that heavily, but coincidentally enough, I've just switched over a service for a current client to using gRPC from REST. And I am most certainly sold. And I think we're going to start using it a lot for the other services moving forward. But before I jump the gun and say why I like it, can we start off talking about what gRPC actually is? And also, I guess, what does it stand for? Which is always the controversial one.
So before we jump into gRPC, I have my 2 cents to add about Carl Saganar. Carl is a friend of mine from the Umbraco community, and he's a very big fan of Docker as well. He has been running workshops and he's been doing talks about Docker. So it's really nice to see Carl mentioned in this podcast here. 3 cheers for you, Carl. And thank you, Dan, as well. It's fantastic. So gRPC is Google's implementation of RPC. RPC being the abbreviation for remote procedure call. So remote procedure call is when a computer program calls a function, basically, but that function execution happens elsewhere. It jumps the network and executes elsewhere. So I, as a programmer, call a function as though I'm invoking it locally, but in reality, it's jumping across the network and getting executed elsewhere. That is RPC in a nutshell for you. And the key word here is procedure. Whenever I talk about RPC or gRPC, it's very procedure-oriented, action-oriented, like do this, do that, get me this, get me that. So if you are someone familiar with the Richardson maturity model, the pyramid, I think it comes in level 0 or level 1, I think. We are not thinking about resources yet. We are doing post methods to get something done for us. That is RPC. Now, gRPC is Google's implementation of RPC. RPC is not something new out there. It's been out for a while. I think if you go back to 1970s or 1980s, you can trace back RPC implementations then. But we all might be familiar with what we had with WCF in the .NET framework. So that is, I think, like a remote procedure call framework in itself. But coming to .NET Core 3.0 onwards, we have support for gRPC in .NET. So I think from what I understand, gRPC is a project managed with a cloud native computing foundation, and Microsoft has written a library of some sort to support gRPC in .NET. So I think with .NET Core, .NET 5, .NET 6, 7, and beyond, gRPC seems to be the favored framework for remote procedure calls. WCF remains .NET Framework only, and I think there's like minimal support for WCF in .NET Core, .NET 6 and forward. There's also Core WCF, which is a community project. But I think if you want official support for a remote procedure call in .NET these days, gRPC seems to be the favored framework going ahead. So starting .NET 3.0 onwards, we have gRPC in .NET. So that is like a brief history of gRPC, if you ask me.
Yeah, I, for one, won't be sad to see the back of WCF, that's for sure.
Oh, no, me neither. I have done like this much of WCF in production after learning about WCF. I'm pretty sure I used WCF like last year in a very old service as well. I was like, oh no, oh God. And when I started picking up on gRPC, I just wanted to see what gRPC is all about. That is where it all started for me. I don't use gRPC in production personally, but ever since I learned about gRPC, it's been intriguing me. It's keeping me interested. So I'm learning more and more about it. So I found this presentation by Srihar Hatti on the .NET channel, where he went through the basics of gRPC. And the first fleeting thought, wow, this is so similar to WCF. The configuration, the way you work with it is very similar to WCF. So I think there is that a developer familiarity with the developer experience when it comes to gRPC as well. So I think Mark Rendell has written an ebook on migrating from WCF to gRPC. I don't think there's a straight migration path from WCF to gRPC, but there is developer familiarity. Plus, if you know .NET Core, ASP.NET Core, you can reuse a lot of that in your gRPC core as well. And one of the first things to talk about gRPC is it is designed for HTTP2 and beyond. It takes advantage of the nice features of the HTTP2, like request multiplexing, the streaming capabilities, which makes it perfect for point-to-point communication. So if you're thinking about browser-based applications, that's probably not a good choice for gRPC or a good way of consuming gRPC services at the moment, because the browser low-level APIs, I think, still doesn't support HTTP2. So if you're thinking about point-to-point communication, if you have microservice-to-microservice communication, if you have your REST API talking to a gRPC, that is all like perfect candidate for using gRPC, because gRPC is incredibly fast.
One of the things I really like about gRPC when I've been doing it is exactly as you said, it's kind of because it's RPC and it's a method call.
Yeah.
You can be quite explicit about what that action is, rather than REST where you're doing CRUD, where it's post, get, put, delete, whatever. It's kind of, you've got to like, okay, how do I fit what I want to do into REST? Where actually with RPC, just like you said, it's like a local call. Well, it's not like a local call, but it's a method name, and you can call it, and you can use DTOs to pass as a request and response to that method, and it just becomes much easier. And also another thing, like just the fact, and we can talk more about what it looks like to develop with gRPC, but the fact that it's typed, means that like with REST API, I've had so many conversations with developers where they've been wanting to create when we've got like a microservice architecture with different REST APIs, and they've been wanting to create all HTTP clients, so it's typed the things to do with that REST API, and that adds a whole bunch of extra work to do. And actually with gRPC, just get that out of the box. It just works. So I really, really like that.
Yeah, absolutely.
So if we take a step back a bit, and for the listeners that don't even know what gRPC looks like, if you were to create a gRPC service, what does that look like? What do I need to create?
Sure. First of all, there's good tooling from Microsoft for gRPC because we have official support. We have starting point in the form of a template. So you can create a gRPC service using your Visual Studio. And what you would find inside that is obviously a NuGet package, which accesses support, but gRPC is essentially a middleware. And gRPC favors contract-based API development. So when you think about the contract, it is actually defined in something called a proto file. So it's a file with an extension .proto. That is your contract definition. So you have your service definition in there and your procedures or the RPCs listed in there. So typically, one proto file would have one service definition, and it would also have the various RPCs in that service definition. Now, this is one part of the proto file. If you think about procedures or functions, it accepts something and it returns something. That's how functions work. With gRPC, that's all in the form of protocol buffers. So protocol buffers is Google's open source mechanism to serialize data. And for a very long time, I thought protocol buffers meant the inputs and outputs for an RPC method. I was proven wrong because the interface definition language, what you see in protofile itself, is a protocol buffer. And the incoming request messages and the response messages, they are also protocol buffers. And there is a representation of the incoming request and outgoing request in the protocol buffers. So they are in the form of what you call messages, with each message having a set of key value pairs or records, with each record having a data type, a name, and a number attached to it. It is actually quite difficult to tell about it rather than just kind of showing that, but I'll try my best here. So each message has few fields, and each field has a data type, a name, and a number. And protocol buffers, it's very special and niche to Google, and it is language neutral, it's platform neutral. It's extensible to the point, it's got even backward and forward compatibility. So with a little bit of TLC right from the beginning, from the design phase onwards of the gRPC API, just like any other API, you can have a perfectly versionable and maintainable service from the word go with gRPC. That's all thanks to protocol buffers. Again, the language neutrality and platform neutrality means I can write a service in C# and I can go generate a strongly typed client, say probably in C++, and then have the two apps communicating with each other. That's all because of the marvel we have, that is protocol buffers. So think of a proto file. You have your service definition, RPCs, your input messages, output messages, all that forms a contract of your API. So if you have a big project, you might have multiple proto files, with each proto file having its own service definitions, RPCs, and the messages. Now, one thing to note with RPC in its basic form, that is gRPC in its basic form, when it comes to RPC, is that it always needs a single input and a single output message. So in its native form, even if you don't have any fields in the input message or the output message, that's fine. You still need something as an input and output. There are ways to overcome that. That's possible, but in a simple form, it needs an input and an output, and it can only have one of it. I cannot have like a hello method which accepts a hello request and something else. If you have a hello request, it can have multiple fields, and it can have values attached to each of that field in the message, if you get it. Now, the messages are transmitted in binary format. So that's one thing about protocol buffers, which keeps the message size small. The second thing is that, think about a JSON blob. You have the name value pairs. So it's the field name along with the value for that field when you get something out as JSON or serialize as JSON. But when it comes to protocol buffers, it's slightly different. Even though you have the name specified in your message, the actual value is marked against the field number that you have on the message. So that's another reason protocol buffers are so small in size. The field name is quite irrelevant when it comes to messages. It's only for us developers to actually make things easier. The underlying framework, the serialization and deserialization, when you encoded in binary, and if you try to decode it, it's against the number that it is encoded. So all the transmission happens that way. So that numbering is very important in protocol buffer messages.
Yeah, that makes total sense. I guess because this is an audio podcast, maybe if we take a step back a bit just so that the listeners can visualize this a bit better.
Yeah.
For a service in a proto file, in my mind, that looks very much like a C# interface. It's like a class, but obviously without bodies. And the syntax is slightly different, but just for listeners that have never ever seen this before, I'm just trying to help visualize. So it's kind of an interface, and you've got a few DTOs. These messages just look like C# classes with properties with slightly different syntax. Yeah. And as you say, it's got a number. Is it called ordinal, I think it's called?
Yeah, probably. I don't know that offhand, but I've always... Sequence number.
Right.
The sequence number is what I've learned it as. Sequence number. It is a sequence number. It needs to be unique per field. Yeah, and it is very important.
So is that related to versioning?
Yes, it is related to versioning. So changing it, removing and adding something new in place of it, that can break your service.
So that sounds like an important thing to know if you're changing existing gRPC code. But
absolutely. But that's like one of the places it can break. But as I said, protocol buffers are incredibly smart when it comes to the forward and backward compatibility. I'm pretty sure we could touch base on it if we get the time to record all that today. But if not, I'm pretty sure I've done a talk about this subject as well. I can point the viewers to the talk as well.
Magic. We can include any links like that in the show notes as well. So, for example, with the versioning, if you wanted to just remove a field, say there was a field that was redundant in one of your messages, would you have to keep that in, or would you remove it and just make sure you don't reuse that number? How does that work?
So, removing a field is generally not a breaking change with protocol buffers, but it could change the behavioral meaning of things, because what happens when you serialize and deserialize protocol buffers is there's no concept of nullability for fields in protocol buffers. That's one of the key things. If I change something or if I remove something on the client side and send it to the server then detects that, hey, I have not got value for this field. So let me just put the default value for that in place. Say if you have an int field with no value sent in or the field removed, when it gets to the server side, it is assigning a value of default, which is 0 in this case. Similarly, for bool, it assigns a default, which is false. So behaviorally, it could affect the application. Similarly, on the server side, if you remove and things get on the client side, the client gRPC middleware, it gives it a default value again. So 0 and default could mean behaviorally different to your client or the server. False and a default bool could be different as well. So removing could affect the behavior of the app. So that's again something to take care of. But if you remove something and you are concrete for sure that you don't want it in place, there are ways to make sure that the field or the field number doesn't get used again. There's a keyword called reserved for that. So I can mark a field name as reserved. I can mark a single field number as reserved. I can actually mark a sequence of field numbers as reserved as well, so that someone who comes later than me doesn't accidentally use it as well. So there are, fences in place or protection in place to make sure that, things cannot go awry very easily with protocol buffers, which is one of the reasons I find it quite interesting as well. Because whenever we think of software, we think forward as well. That is how we do software development. We make sure that it is maintainable in the long run. But gRPC as a framework provides me with that capability in the framework itself, so that with a little bit of work, I can actually get the design of the API up and running and have fully versioned API from the word go, when usually versioning comes as an afterthought most probably, and it's one of the subjects that is most scared of, like people are most scared of when it comes to design as well. You need to really think around it. But gRPC takes care of that for you.
Yeah, magic. You mentioned about nullability as well. So does gRPC not support it at all, or is there any way we can, your example with the int, 0 might mean something, so you might want to say, okay, it's not even set?
Yeah, I think there's a Google, well-known type for that, I think. So Google well-known types are like different types which Google have written, again, which accesses protofile. Just like you would import something into your project using a using using statement to bring in another namespace or something, you can bring in external protofiles into your project as well. So there are Google well-known types. I think there's a Google well-known types for null. I know that there's a Google well-known type for datetime offset, datetime. Similarly, when I spoke about not sending values in or getting values out, there's an empty data type for that. There's a lot of things which Google supports out of the box. I think I have seen a nullable thing somewhere. I'll be surprised if my memory proves me wrong.
It does sound like something because we're used to using null in .NET.
Yeah.
And then it sounds like something that would be quite useful. You did mention like types about timestamps as well. And I know I've seen when I've used gRPC in the past, timestamps seem to have this weird format where it's almost got like two properties, like is it nanoseconds or something, and that always seems really bizarre. But in .NET, I know it's got a built-in function to convert between the two.
Yes. So I think I've used the date time offset. There is a special type from Google for that as well. So which gives me a date time offset or something. It is another Google well-known type, but you can bring that into your proto file. So you bring all these well-known types into your proto file, and then you can start using that data type in your messages so that your server can handle it or your client can handle it for you.
Magic. So we spoke about like these protofiles before and sharing them, and that's your contract. So sharing them, you can just put them presumably in a NuGet package and just share them as you would anything else?
Yeah. So if your consuming client is also .NET, then NuGet package works fine. But with gRPC, one of the biggest advantage is it is the perfect candidate if you want to use it in polyglot systems. That is, if you want to write something in C# and consume it in a totally different language, or I could have the service itself in Node and then consume that within C#. It is a perfect candidate for that. And to communicate with gRPC, we need a strongly typed client, which means that I have to make sure I publish my proto file somehow so that the consuming clients can get hold of it and create a strongly typed client behind the scenes. That brings me to the tooling, which we need to talk about before we jump into this. So whenever you have a gRPC server, to communicate with that, we need strongly typed client. So there is support for gRPC in every well-known language out there. So there's a library, and there's out-of-the-box support as well for some of the languages out there with the tooling that comes in. So it can generate the strongly typed client for you. So with .NET in particular, obviously we have the Visual Studio template, but there's also some tooling in place which kind of abstracts away a compiler, a special compiler called the Proto-C compiler. This Proto-C compiler has understanding of C#, and what it does behind the scenes when I have a proto file is it generates C# code for me. So on the server, I can actually tell it what type of C# code to generate as well. So if it's a server-side configuration that I'm using, it generates the code for server-side usage. And if it's for the client side that I'm trying to generate the code, it generates the code for the client side. I don't know whether it's the same kind of configuration for other languages, but I'm pretty sure it could be the same way it works. So if I'm setting the code on the server side, especially for .NET, what it goes and does behind the scenes is, for every service that I have in my proto file, abstract class is getting generated. And every RPC method that I have in my service goes to become a virtual method in that abstract class. So that is like basic C# keywords being used, which means if I need to give it my own implementation, I can create a class of myself, inherit from the base abstract class, override the methods, and give it my implementation. So that is on the server side. But when it comes to the client side, it generates something called a strongly typed client and a method stub. So if you have an RPC called say hello on the proto file, it generates a say hello stub in the client for me so that my client call looks like the client name, the strongly typed client name variable dot say hello on the client. But in reality, that say hello is actually using some configuration behind the scene to jump the network, go and actually execute the method in my server and come back with the response. So there's a lot of code generation in place for us. And it's the Proto-C compiler which helps you do that. So if your clients are C# or .NET-based clients, NuGet packages can work perfectly fine. Otherwise, you need to publish your proto file somehow. It's up to you how to do that. I was thinking about minimal APIs the other day. So you can actually have a minimal API in your gRPC project set up using the app.map get endpoint so that your clients could go into the proto file or download a copy. Or you could have your proto file, say, hosted somewhere, and you could have a service reference to that. That's one way of doing that. But you have to find a way of sharing that proto file. If it's .NET clients consuming it, yeah, class libraries, NuGet packages works perfectly. But gRPC, we have to be a little bit more careful because there could be clients in other languages consuming that. So we need to find a good way or a standard way of doing that.
Yeah, I think there's also another option where you can, and I don't think this is recommended in production. I'm not sure. I don't know the term, but you can get it so that your server side is almost like publishing what the protos are, and the proto can be inferred. It can basically get it from the server. It's got a term. Let me just. What am I doing?
Server reflection?
Yeah, I think that's it. And there we are.
Because some of the testing tools like Bloom RPC and Postman and gRPC UI, it uses server reflection to gather information about the proto file. So I think the server reflection is probably the term.
Yeah, that was it. So I've got the code up now and I'm just having a quick look at it. And I can see that, so in my server side, program.cs, I've actually got if development. So it's kind of, I've not got it in production, but then app.map gRPC reflection service. And then that's kind of enabled. And in fact, you've just pointed out something I was going to mention about Postman. I think that's quite recent that they've added gRPC support. And when you go in Postman and you put the URL and you get a drop down, you can choose to upload your proto files, or you can say to infer it using this reflection endpoint, or there's like different options, and it just works magically. It's fantastic. Yeah.
Have you tried gRPC UI?
I've not heard of that.
Okay, so gRPC, there's this command line called gRPC curl, and gRPC UI is built on top of gRPC curl. So what it does is you can install that tool in your local computer, and then I can run my service, and then I can issue a command gRPC UI on localhost this port, and it spins up the browser for you and opens up a nice UI. So I don't even need to upload my proto file or refer to proto file. It just gathers it for you. It's almost like having Swagger. I wouldn't say Swagger or OpenAPI. It's almost like that because you can actually then choose your services to interact with. I can issue my request commands. I can even add headers and then get back the results. I can actually see what the response headers and trailers and so on. So when I demo things, I usually use gRPC UI because it is really seamless for me. You can bake it into the application and then use that on the development side.
I'll definitely make sure I include a link to that in the show notes. I remember a couple of years ago when I was doing another project I was working on, but it wasn't me that implemented this, but they were using gRPC there. And the bit consuming the service, there was stuff in, as you mentioned, Node and stuff in .NET. So we had to publish the Node stuff as an NPM package, the proto files in an NPM package, the same proto files, and then also in a NuGet package. But it was the same proto files, so the same pipeline just made sure that it spat them both out as an artifact, then put that to the NPM package feed and also the NuGet package feed. And then like both, as you say, both, regardless of language, whether it's Node or .NET, both can just consume it. So that was really, really nice.
Exactly, yeah. If you want to actually make your profile visible to, say, the developers out there in development phase, you could stick to controllers or have a minimal API in place. I think Anthony Giretti has written a blog post on either using controllers or minimal APIs. I can't remember which one. But when using minimal APIs to do things like this, it just felt so natural. It's a really good use case, and your developers get to see things before even they consume them as well. So it's nice that you can bring in things you already know about ASP.NET Core into gRPC as well.
You were talking before about the generated files, how from the protos, the tooling just generates all these files. Those files go into the obj folder, so they don't go into source control. Because I know that in the past, when you've had auto-generated files, sometimes it goes into source control and you end up with horrible, messy, like even WCF with the clients, it's kind of, all of that goes into source control and it's just a mess. Where gRPC, the stuff that's in your project that's not in your intermediate folders, like your bin and obj files, are quite clean. It's pretty much just the proto files, and that is so nice.
Yeah, absolutely. As you rightly said, it goes into the object folder, the intermediate resources. What happens is the tooling takes care to make sure that whatever you have specified in your proto files, when it gets generated into the corresponding language you're thinking about, all the coding best practices and standards and the naming conventions, all of that is taken care of for you. So I'm talking from a C# perspective. If you look at the generated code, everything that is recommended as a Microsoft standard for C# coding is in place for the generated code. That's one thing about the code. And there are two files getting generated for each proto file. So there is a file which puts all the messages as plain POCOs in the object folder. And there is another file which lists all the RPCs. And basically, it's a partial abstract class with virtual methods. So if you want to actually see how the various different data types in your message, that is protocol buffer messages, maps to the corresponding C# types and the .NET types, this is a good way to learn that as well, because all that messages are POCOs. So you can actually see what is going on there. And your RPCs are abstract classes with virtual methods, which by default throws exceptions saying unhandled, unimplemented.
Is that unhandled exception?
No, it's sorry, not unhandled, unimplemented exception.
Oh,
It's an RPC exception.
you see what I did there?
No, not unhandled, sorry, unimplemented exception. So again, it's a good way to learn about things and then gives you enough keywords to Google upon and learn as well, which can get interesting, I think.
So I know with all these types and stuff, you've got a concept of a stream as well.
Yeah.
You can choose whether you're using, is it called, I never know how to pronounce this, Unuri or whatever it is. But so that seems to be the standard stuff, but you can also use a stream as well.
Yeah.
When would you use streams versus this Unuri, whatever it's called?
So streams is when you want to get a stream of data out from the server, or you want to send packets of information to the server. So there are various different modes of gRPC, apart from Unuri, which that's how I call it, sorry. Unuri, which is the normal client's server. You get a message in, you get out the response from the server. But you can have client streaming, in which the client sends in like a stream of messages to the server, but the server responds back with a single response. You can have server streaming, which is the opposite of client streaming. So in server streaming, client gets a single message into the server. The server knows that is client, indicating that I should start the stream, and the server starts sending a stream of messages. And there's a mixture of both as well, called bidirectional streaming, in which you can send a stream into the server, you can send a stream out from the server as well. So when you're thinking about large volumes of data, but you do have the facility to break it down into chunks and send it back, then that's a perfect use case for streaming. If you want to think about something like a large file upload from the client, there are some barriers in place, because with gRPC, what I read is that it is all binary information, which is good. The packet size is naturally low. However, on the client side and server side, this message is loaded into the memory before it is sent out. And on the server side, it is loaded into memory again before it is deserialized as well. So there is resource usage in both client and server. So naturally, I think there is a limit on the packet size on the server. So if you're thinking about a large file upload, you might be better off breaking it into smaller chunks and sending it as stream of data. If you're thinking about 1,000 items in a list, again, you have the facility to send that in a stream and gain on performance as well, because the packet size is so small and the resource allocation and resource usage gets so small as well. So if you can actually break your data into smaller packets and send it to the server or send back from the server, then that's a good way of using streaming as well. Again, making use of the HTTP2 facility that we have with streaming. We are thinking about HTTP2 here, but with .NET 6, I think there was at least experimental level support for HTTP3. I don't think it was experimental. It was support for HTTP3, and I think gRPC in .NET was the first kind of implementation of gRPC to have official support for HTTP3 in gRPC as well. So we are kind of trying to learn the basics of HTTP here, at least me personally, and we have support for HTTP3 in gRPC, which is like, oh my God, this is blowing my head away.
Then you get, like, if the calling code is .NET Framework, and you've got to fall back to one point, like HTTP 1. I know for this project, because we're doing that, we had to, what's it called? Let me 1 second. I've still got that program.cs open. So on the server side, what is it? I'd like say to use something called gRPC Web, and that's a different, I think that just goes over HTTP protocol.
Yes.
But so by switching that on, it means that .NET Framework can talk to it. And
yes.
Yeah, it's just these little edge cases where it depends what the calling code is. And yeah, .NET Framework can be a pain at times.
There is gRPC Web, of course, if you want to make use of gRPC in browser-based application, but then you lose out on the client streaming and bidirectional streaming because you can't support that with gRPC Web, which works over HTTP 1.1. Because what it does is there's some kind of work it does to convert between the HTTP 2 and HTTP 1.1 requests. I think that is how it works. But coming back to browser-based applications and using this in .NET Framework, potentially what .NET 7 is going to give us with gRPC might actually be a problem solver as well. What you have with gRPC in .NET 7, the biggest feature is JSON transcoding. So suppose you have a gRPC service, then you can annotate the protofile with bringing in a protofile from Google and having the Google HTTP annotations. What you can do is you can invoke your RPC calls using HTTP verbs over a URL. Now, this is where I told you that this is going to get interesting because gRPC is all about procedures, actions. While with JSON transcoding, one big part of it is you can develop RESTful APIs on top of your gRPC APIs. This is like, okay, this is a interesting irony for me. When I talk about gRPC, it is all about procedures. And then this thing comes in where it says you can develop RESTful or HTTP APIs using gRPC, which is very interesting. So what you effectively get is for every protofile, you can choose to annotate it with some special annotations, give it a URL pattern over which it can listen to, and specify which HTTP verb that it can listen to as well. And I can browse and connect to that endpoint like a RESTful endpoint. So I can have a get issued, I can have a post issued, I can have a put, delete, or patch issued, or even hidden options issued. But the underlying thing is that you only need these annotations in your protofile. You don't need to do that on your code. The code is still the single implementation that you give it for your gRPC service. It's the same code, but you are talking to the same code using gRPC as well as a RESTful way. So that's one way you can actually consume gRPC in your browser-based applications. I know that from Preview 4, when it was released to .NET RC 1, things have changed. There's support for server streaming as well, which is quite nice to see. But obviously, client streaming and bidirectional streaming still not supported because we are talking about browser-based APIs here. So that is one interesting thing. It was actually an experimental feature in .NET 6 called gRPC HTTP API. Because of the popularity, it's actually made its way into .NET 7 as a full-fledged supported feature, which is again nice thing to talk about because we are recording in October, the month of Oktoberfest. So talking about community popularity about a feature making into .NET 7 is a great thing.
Yeah, and .NET 7 next month.
Yeah.
So we're not far away at all.
So .NET Conf agenda is out. I am looking forward to the various presentations. I'm quite excited to learn about what's upcoming in .NET 7 because it just gets better and better.
Oh, no, definitely. Once a year now as well.
I know. It's predictable release cadences and, you know which ones are the long-term supported versions and so on. So it's quite easy to make a decision on what version of .NET your project goes on as well. So which is quite good.
I'm still trying to get my head around REST on top of gRPC. At first I was thinking, why? But now I'm thinking, oh, actually, I can think of a few.
Yeah.
Maybe. But yeah.
We are talking about tech and software. There is a genuine use case for everything that's out there, I think. One example is you don't want to create a REST API with all this code duplicated. That's a perfect use case for it. If you want your gRPC apps to be consumed in a very simple way by your browser-based clients, perfect. We are talking about level 0 or level 1, which is an RMM model, that level of HTTP APIs, which is perfect. But I'm just thinking about more RESTful APIs, which has the Hatios in place as well. How can you do that? How would you do that? Or can you do that with JSON transcoding is a fun question.
Presumably you'd have to format the response in a certain way and make sure that you included the relevant URLs and everything.
Yeah, exactly. Now, another question is, can I have certain fields returned for just the gRPC aspect? Can I have certain fields returned for just the REST aspect? Because the two request type, the MIME types are different. For gRPC, it's application gRPC, and for the other one is application JSON that comes in. So can I demarcate between the two and make sure that when the response goes back, there's additional things to it, maybe interceptors? You can play with your response messages and request messages. So this could be a way of tinkering with the response message and sending in some Hatios compliant JSON as well. Don't know. That'd be interesting. Food for thought.
So what are interceptors? Have we actually covered that yet? We haven't covered that, have we?
No, we haven't. So I haven't spoken much about interceptors in my talks, but interceptors are like little pieces of code which you can use to intercept the call. Basically, it goes by what it says in the tin. It intercepts something. So if you want to run some code before your call is sent out to the server, or maybe the response is sent back from the server to the client, you can have interceptors in place. So it runs for all gRPC requests rather than a middleware which runs for all HTTP requests. So this is on the gRPC level. So the fun thing is you can have interceptors at the client side and the server side as well. So if it is on the client side, I can intercept the request before it goes out to the server. It can actually tinker with the request that is sent out, add headers for authentication, etc. And on the server side, I can intercept the incoming request as well as I can intercept the outgoing response as well before it goes out. So there is that functionality on both sides. So that's another thing that I want to play around and see as well. It sounds interesting, a lot of possibilities with it, like logging, validation, all sort of that things. So that is like an interesting concept.
Yeah, that does sound really interesting. Another concept which I just briefly read about, and I know that you're going to mention it, something called deadlines, which sounds quite fascinating.
Yeah. So we have the streaming capabilities with gRPC, and streaming can be often a long-running operation. So there are two concepts actually to stop a long-running operation. One is deadlines, one is cancellation tokens. So deadline is, as it says on the tin, it's a deadline. I'm giving you a deadline upon which you have to cancel what you're doing and stop everything. So I can give the server a pre-configured deadline saying that after this point of the time, you have to stop processing. And the interesting part is with a bit of configuration, a property added on the server side, you can actually trickle that deadline down into your own services like the long-running database operations or something to actually stop that from happening as well. Because it's no use if I just send the deadline to the server, but don't trickle down into my services. So we have to take care of that as well. But you can make that happen. Cancellation token, from what I understand, is more on the client side. The client gets more control over it. So I can send in a cancellation token and say that I can send in a cancellation token, and if I choose to cancel the long-running operation from my end as a client, I can choose to do that. So it serves the kind of same purpose, but on different sides of the application.
Yeah, that cancellation token makes it feel even more like just a local function call.
Yeah.
Which is quite nice.
So it's all that client stub. And when you connect to a gRPC server, what a client needs is something called a gRPC channel. So that gRPC channel is your long-running or the long-standing connection to the server. That's a very heavy object. That is where you configure which URL to connect to and generates client of that gRPC channel. That's where you have your configuration in place. That gRPC channel is what helps with everything. So once you have your gRPC channel, the client set up, I can send in my cancellation token with every call that I send and then do everything that I need.
That's very cool. With the deadline thing, I just like the idea that it gets passed down your services.
Yeah.
I never know whether it's downstream or upstream because whichever
Yeah.
whichever article I read says it the opposite way, but I say downstream. So, but
Yeah, downstream, yes, because you're trickling down levels for, at least for me, so it's downstream. I agree with downstream in that one.
Well, I've never understood it because I know some of the service meshes for like Kubernetes and stuff. Like I know Istio refers to it the other way around, and I get really confused by it because I think downstream because, as you say, the flow is going downstream. So I'm thinking about the flow of water. So I don't understand that, but yeah, it's kind of cool. So before we wrap up, shall we do dev tips?
Yeah, sure. This is a dev tip. It's an article which I read about experimental web transport over HTTP 3 support in Kestrel. So the whole idea behind this is a new kind of draft specification for a transport protocol similar to WebSockets. So it's real-time applications, but you have the streaming capabilities again. So there is kind of relations to gRPC as well as I spoke about Azure Web Pub Sub in the past, which that helps you create real-time applications. So I'm looking at this from that perspective as well. So it seems like there is a new transport protocol called Web Transport in place, which helps you have real-time applications, which is similar to WebSockets, but with a bi-directional data stream. So it is a lot of work in WebSockets if you want to open up a next connection, send data in, but this again looks like it's making use of the HTTP 2.3 request multiplexing and streaming capabilities. I can share this article with you. I just skimmed through the article, but I was like, okay, this looks fun. It could change a lot of things for Azure Web Pub Sub as well, which is interesting. So I can share this article with the podcast notes as well so that everyone can have a read. It looked really interesting. I haven't played around with much. I haven't actually had the time to go through the code single line by line, but the idea sounds promising. There's actually some sample code and sample apps in place as well.
Oh, nice. I look forward to reading. And we'll definitely include it in the show notes. So my dev tip, I'm afraid, is a bit off topic. So my dev tip is basically to put all your configuration stuff into a Git repository. And I recently wrote a blog post about this, which I'll include in the show notes. And I have things like my Git config, PowerShell profile, my Windows terminal config, my Posh config, Chocolatey, Vim, and lots of different other stuff in the same Git repository. And I just find it makes me much more organized about my configuration. I'm not worried about losing it. If I'm on another machine, I'm syncing my Git repository. And all of my changes are much more intentional. So if I'm using, I don't know, whatever it is, Vim, and I think, I want to change that, configure that, or Git or whatever it is, then I change in my vimrc or .git config what it is, and then I'm creating an explicit commit. So it's very meaningful, pushing it to my Git repository with all my config stuff in. And also, when I'm not scared of losing it all, that history, I'm much more motivated to make tweaks and make my setup even better. Yeah, so I'll include a link to the blog post and I'll talk about how I do it using symlinks. And there's something called dot files, so a dot file refers to like .git config or dot whatever, because a lot of configuration files start with a dot. But from what I understand, the concept of dot files are pretty much what I explained, where you create symlinks so that you can put all your configs for different things in the same Git repository. But when I did it, I didn't know it was called dot files, but there's a whole community around sharing dot files and that kind of thing. So that's quite cool.
Oh, wow. That's interesting as well, yeah.
So that's my dev tip. So before we wrap up, where's the best place for listeners to reach out to you if they've got any questions?
You can reach out to me on Twitter. So my handle is Poornima Nayar. So it's a long name to spell, I understand, but obviously it'll be in the show notes.
And I must say, I've never, ever known anyone that's so fast in replying to Twitter DMs.
Oh, no. The reason is, as I explained, if I leave things like this to later, it often gets forgotten amongst the mess that I have with my hard work that I'm putting in place for something at work. So I don't want event organizers or podcast organizers like you to kind of be delayed because I don't reply. I just make it happen then and there. Because it has happened, someone actually replied, asked me something, I didn't reply on time, and it got forgotten.
I've got to say, I just wish everyone else was as fast to reply as you, because it does make it difficult, especially when you're waiting days for replies. The latency between organising something becomes really, really difficult. So thank you.
Yeah, I don't like uncertainty at all. Like, I'm a planner. I do things in a very specific way, and I like to plan things. Because I like planning things, I don't like others to be left unplanned for me. So no. It's a privilege to be a part of a conference as a speaker, or a podcast like where I am joining the show as well. So it's a privilege. So the least you can do is be prompt on the reply. Yes, I've been really fast in replying to you because it's Twitter and Twitter pings me. But yeah, that's fine.
The privilege is all mine. So thank you so much for joining us on the show. It's been so much fun chatting with you about gRPC.
Yeah, absolutely. I've had a blast on the show. I loved discussing this. This is so much fun.
And I remember to press record at the start because for the listeners, I almost forgot. So that would have been just experimenting with a new platform for recording. So I almost forgot to press record. So phew, that's a relief. And thank you everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you enjoy the podcast, please do help me spread the word on social media. I normally use the hashtag #unhandledexception, and I can be found on Twitter @Dracan, DRACAN, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And we'll include links to all the stuff we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.